Welcome to my AP FRQ video project. Today I'll be covering 2011 question number 6. The question states, let f of x equals sine of x squared plus cosine of x. The graph of the fifth derivative of f of x is given. Part A says, write the first four non-zero terms of the Taylor series for sine of x about x equals 0, and write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. In order to obtain the Taylor polynomial for sine of x, we must find the first four derivatives. So the first four derivatives of sine of x are listed on the screen. And as we can see, every fourth derivative, sine of x cycles back around. So the fifth derivative of sine of x is equal to sine of x. When x equals 0, sine is always 0. So to find the first four non-zero terms of the series of sine of x, we must consider the first four cosine terms. So, based off the cycle we established on the previous page, we know that the first derivative, the third derivative, the fifth derivative, and the seventh derivative are all cosine. And when evaluated at 0, we get 1, -1, 1, and -1. Using this information, the first four non-zero terms of the Taylor series for sine of x around x equals 0 are x minus x cubed over 3 factorial plus x to the fifth over 5 factorial minus x to the 7 over 7 factorial. To find the first four non-zero terms for sine of x squared, we can simply square the x terms of the series for sine of x. This gives us x squared minus x to the 6 over 3 factorial plus x to the 10 over 5 factorial minus x to the 14 over 7 factorial as the first four non-zero terms for sine of x. The method we used in the previous slides works great, but to save time during the AP test, we can simply remember the identity for the summation of sine of x, which is summation from n equals 0 to infinity of -1 to the n x to the 2n plus 1 over 2n plus 1 factorial. By writing out the first four terms of the series, we obtain the first four non-zero terms for the Taylor series for sine of x. To find the first four terms of sine of x squared, we can simply sub x squared into the summation for sine of x, giving us summation from n equals 0 to infinity of -1 to the n x squared to the 2n plus 1 over 2n plus 1 factorial. And by writing out the first four terms of this series, we can obtain the first four non-zero terms of the Taylor series for sine of x squared. The scoring rubric for part A is as follows. 1 point is obtained for having the correct terms for sine of x, and 1 point is obtained for having the correct terms for sine of x squared. No partial credit is given for this problem, so make sure to solve each term correctly. Part B states, write the first four non-zero terms of the Taylor series for cosine of x about x equals 0. Use this series and the series for sine of x squared, found in part A, to write the first four non-zero terms of the Taylor series for f about x equals 0. To find the first four non-zero terms of cosine of x, you can repeat the process from part A with cosine of x, or, by recognizing that the summation for cosine of x is equal to summation from n equals 0 to infinity of -1 to the n times x to the 2n over 2n factorial, we can find the first four terms of the summation, which are 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6 over 6 factorial, which are the first four non-zero terms of the Taylor series for cosine of x. In order to prepare for the AP test, be sure to remember the summation notations for sine of x, cosine of x, and e to the x at the very least. This will help you save valuable time while taking the AP test. F of x is given as sine of x squared plus cosine of x. By combining the terms of the two series, we obtain 1 minus x squared over 2 factorial plus x squared plus x to the 4 over 4 factorial minus x to the 6 over 3 factorial minus x to the 6 over 6 factorial. And by multiplying top and bottom of x to the 6 over 3 factorial by 5 times 4 times 3, we can rewrite it as 120 times x to the 6 over 6 factorial. By combining like terms, we obtain 1 plus x squared over 2 plus x to the 4 over 4 factorial minus 121 x to the 6 over 6 factorial, giving us the first four non-zero terms of the Taylor polynomial for f. 1 point is given for correctly finding the series for cosine of x, and 1 point is given for correctly finding the series for f of x. Just like part A, no partial credit is given, so be sure to solve each term correctly. Part C says, find the value of f raised to the 6th of 0, or the sixth derivative of f when evaluated at 0. To find the sixth derivative of f, evaluated at 0, we must recognize that the sixth derivative of f evaluated at 0 over 6 factorial represents the coefficient of the sixth degree term for the series f of x. The coefficient for the sixth degree term of f of x is negative 121 over 6, which means that the sixth derivative of f evaluated at 0 is equal to negative 121. 1 point is obtained for finding the correct value of f raised to the 6th of 0. A common mistake in this problem would be to use the coefficient of the sixth term rather than the sixth degree term, so it is important to be clear on the meaning of f raised to the 6th of 0. Part D states, let p sub 4 of x be the fourth degree Taylor polynomial for f about x equals 0. Using information from the graph of the fifth derivative of f of x shown above, show that p sub 4 of 1/4 minus f of 1/4 is less than 1 over 3,000. The notation given can be interpreted as follows. Show that the max Lagrange error for the fourth derivative of x on the interval x is larger than or equal to 0 and less than or equal to 1 over 4 is less than 1 over 3,000. The Lagrange error for the fourth derivative of x is represented by the maximum value of the fifth derivative of x over 5 factorial times 1 over 4 minus 0 to the 5 on the interval 0 is less than x, which is less than 1 over 4. Using the graph, we know that the maximum value of the fifth derivative of x on the interval x is larger than 0 and less than 1/4 is less than 40. Therefore, we know that p sub 4 of 1 over 4 minus f of 1 over 4 is less than the Lagrange error, which is the identity, which is less than 40 over 5 factorial times 1 over 4 to the fifth. Because we know that the fifth derivative of x on the interval is less than 40. 40 over 5 factorial times 1 over 4 to the 5 equals 1 over 3,072, which is less than 1 over 3,000. This means that p sub 4 of 1 over 4 minus f of 1 over 4 is less than 1 over 3,000. The square rubric is as follows. 1 point is obtained for correctly recognizing the form of the Lagrange error, and 1 point is obtained for correctly showing that p sub 4 of 1 over 4 minus f of 1 over 4 is less than 1 over 3,000. Here are some additional FRQs I compiled if you need extra practice on the topics we discussed in this video. Thanks for watching.